Hi everyone! Today we'll be taking a look at how to solve linear systems using graphing. Here's today's FLT. Given a linear system, I will be able to solve the system by graphing. So first things first, what are linear systems? So first, let's look at the definition of linear equations. So a linear equation is an equation for a straight line. So all of these are examples of linear equations. For this lesson, we'll be focusing on linear equations that look like this. So ones that are written in slope-intercept form. And a system of linear equations is when you have two or more linear equations working together. So it's like a set of linear equations. Here's an example of a linear system. We have two linear equations here, both written in slope-intercept form. And when we solve these linear systems, a point x comma y is a solution of that linear system if it's true. So if it works for all equations of the system. And there's three types of solutions we can have. So our first type is where the two lines intersect at one point, so there's one solution. So the solution is the point where your two lines cross. And then if your two lines never intersect, so if they are parallel lines, then there are no solutions because the lines never touch each other. Lastly, if the two given equations describe the same line, then there are infinite solutions because any point on the line would work for both equations. So today, we'll be solving linear systems by graphing. Here is our first example. Solve the following system graphically. So we have two equations. The first one is y equals 5 over 2x minus 8. And the second equation is y equals negative half x minus 2. So we're going to be taking a look at both equations, finding the slopes, the y-intercepts, and then graphing those lines on the coordinate plane. So we're going to take a look at the first equation, y equals 5 over 2 times x minus 8. So I'm just going to write it over here. And this is already in slope-intercept form, so it's actually pretty simple to find the slope and the y-intercept. So our slope, m, equals 5 over 2. We'll rise 5 and run 2. And then what about our y-intercept? Well, b equals negative 8. So b equals negative 8. And again, this is based on the slope-intercept form, which is y equals mx plus b. All right, so since b equals negative 8, our y-intercept is at 0, negative 8. So let's graph this. I find 0, negative 8, and then I rise 5 and run 2. And I connect these dots to get my line for this equation. So here's the first line. Next, let's graph the second equation. So we have to graph both lines to see where they intersect. So our second equation is y equals negative 1/2 times x minus 2. Our slope, m, equals negative 1 over 2. And then our b value is negative 2. So b equals negative 2. Our y-intercept is at 0, negative 2. So I graph this line, start at the y-intercept, go down 1, right 2. I connect the points, and I now have my line for the second equation. And notice here, the two lines intersect at the point 2, negative 3. So the two lines are crossing at this point. So this means that our solution for this linear system is 2, negative 3. So for today's lesson, we're using graphing to see where the two lines, so where the two linear equations intersect. For our next example, here is our linear system. We have y equals negative 2/3 times x plus 6, and also y equals 2x minus 2. Let's start with the top equation. So y equals negative 2/3 times x plus 6. Let me write it down over here. And we have to find the slope and y-intercept. Our slope, m, equals negative 2 over 3. And our y-intercept, b, equals 6. So we can find our y-intercept as 0, 6. So I'm going to graph it. I start at 0, 6. I move down 2 and to the right 3. And I'll connect these two dots to create my line. So this is the graph of our first equation. Now let's look at the second equation right here. So I'm going to write it over here. We have y equals 2x minus 2. Our slope, m, equals 2, which I can write as 2 over 1. And my b value here is negative 2. Since my b value equals negative 2, I know that my y-intercept is the point 0, negative 2. So I can graph this by finding the y-intercept at 0, negative 2. And then I move up 2 and then right 1. I now have my second line, and these two lines intersect at this point right here. The point of intersection is 3, 4. So my solution is 3, 4 for this linear system. You might be wondering, how do we know if 3, 4 is really our solution for this system? We can check by plugging this point into each equation. So we're going to replace the x values with the x value 3 of our coordinate point. So for our first equation, y equals negative 2/3 times x plus 6, we're going to replace the x value by 3. So we're going to calculate negative 2/3 times 3 plus 6. I've replaced the x with the 3. Negative 2/3 times 3 is negative 2, and then the plus 6. And negative 2 plus 6 equals 4, which is the y value of the coordinate point we found. So it's true for our first equation. Let's check for our second equation. Y equals 2 times x minus 2. Replace the x with the 3. So we have 2 times 3 minus 2. I replace the x with this 3. 2 times 3 equals 6. And we have the minus 2. 6 minus 2 is 4. Since both equations are true, we know that we solved the linear system correctly. Let's look at another example together. So let's solve this following system graphically. We have y equals negative x plus 5 and y equals negative x minus 4. Let's look at the top equation first. We have y equals negative x plus 5. And the slope is right here. Technically, it's a negative 1. The 1 was just invisible. So our slope m is negative 1 over 1. And our b value is 5. So that means our y-intercept is at 0, 5. I start at my y-intercept, move down 1, right 1, and then I'm going to connect these points. And here is my line of the first equation. Our second equation is y equals negative x minus 4. Here, our slope, again, there's an invisible 1. So our slope m is negative 1, the same as our first equation. But our b value here is negative 4. So our y-intercept is at 0, negative 4. So I start at the y-intercept, 0, negative 4, put another point, connect the points to get this line. What do you notice about these two lines? These lines are parallel, so they're never going to touch. There are no solutions to this linear system because there are no points of intersection. So if the two lines have the same slope but have different y-intercepts, then the lines are going to be parallel, so there would be no solutions. Let's look at one more example together. So here, our linear system is y equals 3x plus 4 and y equals 3x plus 4. You probably noticed something already. Let's focus on the first equation, y equals 3 times x plus 4. So write it down. And here my slope is m equals 3, or m equals 3 over 1. And our b value is 4. So our y-intercept is at 0, 4. I graph this. The slope is 3. Connect the points, and I have my line. So this is the line of the first equation. But notice when you look at the second equation, it's literally the same exact thing. So the line is going to be the exact same. And that means that any point on this line, wherever it is, would work for both equations. So in this case, we have an endless amount of solutions. In other words, we have infinite solutions for this system. If you have the same exact line, you have infinite solutions. So now that we've walked through some examples together, here's just a very quick tutorial of how to work on your practice problems on Delta Math. So on Delta Math, you'll be given a linear system. And so what I'd recommend doing is maybe using scratch paper to write down the slope and y-intercept for both of the equations. Sorry, my writing's so messy right here, oh my goodness. But yeah, identify M and B. You're going to click on 2 points to create your line. So this is the line for the first equation. Now let's take a look at the second equation. Our slope is -1/3. And then our y-intercept, or our b value, is at -2. So I find my y-intercept, 0, -2. Make sure it's a slope of -1/3. And I look at where the two lines intersect. They intersect at -3, -1, so I submit that. And yay, I got it correct. So this is how you'd walk through the problems. So as a review for today's topic, a linear system is a set of equations of straight lines. You can find the solution of a linear system by graphing the lines and seeing where they intersect. You can have one solution, no solutions, or infinite solutions depending on the linear system. Great work today, and please remember to submit your notes on Canvas.